So let's move on to example 2. Now in this example, we are going to find the absolute minimum and maximum of the function f of xy on the triangular region in the first quadrant bounded by the lines x equals 0, y equals 0, and then y equals 9 minus x. So as usual, the first thing we need to do is to find the critical point of this function, and then we make sure that the critical point is inside of this triangular region. Now if that is the case, we try to find the value of the function at that point. So let's try to find the critical point by finding fx and then fy, and then we set each of them to 0, and then we find the values of x and y. So for fx, that is the first order partial derivative of the function with respect to x. So we differentiate this function with respect to x term by term. You differentiate 2, that is a constant, you have 0. You differentiate 2x, and then you have 2. You differentiate 4y, and then it goes to 0. You differentiate negative x squared, that becomes negative 2x, and then you differentiate negative y squared, that also goes to 0. So we have fx to be equal to 2 minus 2x. Then we move on to fy, first order partial derivative of the function with respect to y. We differentiate the constant, which is 2, and it goes to 0. 2x also goes to 0, and then 4y becomes 4. Negative x squared goes to 0, and then negative y squared becomes negative 2y. Next, we are going to set each of them to 0. So we have 0 equals 2 minus 2x, and then 0 equals 4 minus 2y. Let's try to find the values of x and y. So we transpose negative 2x to the left hand side. We have 2x equals 2. We divide through by 2, and thus we have x to be equal to 1. Again, for fy, we transpose negative 2y to the left hand side. We have 2y equals 4. We divide through by 2, and then we have y equals 2. So this is the value of y. Therefore, we have the critical point. We have the critical point 1, 2. Now we need to verify whether or not this critical point is inside of this triangular region. Now to do so, we first of all need to represent the triangular region, which is bounded by the lines x equals 0, y equals 0, and then y equals 9 minus x graphically. So we consider the first quadrant of the xy plane. So let's say this is y and that is x. So when you consider the xy plane, this happens to be the first quadrant, the second quadrant, third quadrant, and the fourth quadrant. So we are going to focus on the top right corner. So this is the origin. This is the origin, point 0, 0. And then along the x-axis, we have the line y equals 0. On this line, the value of y is 0. Along the y-axis, we have the line x equals 0. Also along this line, we have x to be 0. Now, to find the endpoints on these two axes, that is the x-axis and the y-axis, we need to work on the line y equals 9 minus x. Now, for the line y equals 9 minus x, we need to find the x-intercept and then the y-intercept. So considering this line, to find the x-intercept, that is where the line cuts the x-axis. At the x-intercept, y is equal to 0. Therefore, we are going to substitute 0 for y in this equation. Therefore, we are going to have 0 equals 9 minus x. And thus we transpose negative x to the left hand side so that we have x equals 9. So the value of x is equal to 9. Also for the y-intercept, that is where the line cuts the y-axis, we have x also to be equal to 0. Therefore we substitute 0 for x, and then we have y equals 9 minus x, and x is 0. So this becomes y equals 9. Therefore, for the x-intercept, we have the point x is 9, y is 0. For the y-intercept, we have the point x is equal to 0. and then y is equal to 9. So we have the point 9, 0 and then 0, 9. Now we come to the xy plane. We have the point 9, 0. So this is 9, 0, and then we have this to be 0, 9. So these are the endpoints, including the origin. So we are going to have the triangular region. This is the triangular region. So let me use a different color. So this is the triangular region bounded by the lines x equals 0, y equals 0, and then y equals 9 minus x. Also remember that the absolute minimum or maximum may either occur inside of this region or on the boundary of this region. Now we have the critical point to be 1, 2, and this critical point on the x-axis, you can assume this point or this mark to be 1 and that to be 2 on the y-axis. Hence we have our critical point somewhere around here. So this happens to be the critical point, that is 1, 2. Now since the critical point is found inside of this triangular region, then we need to find the value of the function at the critical point. So we have f of 1, 2, that is equal to, so considering this function, we are going to substitute x with 1 and then y with 2. So we have 2 plus 2 times 1 plus 4 times 2 minus 1 square minus 2 square. Now 2 plus 2 is 4 plus 8 is 12 minus 1, that is 11, minus 4, that is 7. So we have f of 1, 2 to be equal to 7. So this is the value of the function at the critical point. Now the next thing we are going to do is to try to find the extreme values of the function on the boundary of the triangular region. We want to investigate the points along these lines. So let's label this. We have this to be L1, that to be L2, and then this to be L3. Notice that this is the line y equals 0, x equals 0, and this is y equals 9 minus x. So let's try to consider each of the lines one after the other. So for the first line segment, that is line 1, we have y to be equal to 0. Y is equal to 0. And then we have x having an interval from 0 to 9 inclusively. So that is 0 is less than or equal to x is less than or equal to 9. Therefore we have f of xy, and that's equal to f of x0, and this is equal to, now considering the function, we have 2 plus 2x plus 4 times y, which is 0, minus x squared minus y squared, and that's 0 squared. So 4 times 0 is 0, and then negative 0 squared also is 0. Therefore we are going to have f of x0 to be equal to 2 plus 2x minus x squared. Therefore when x is equal to 0, we have f of 0, 0 to be equal to 2 plus 2 times 0 minus 0 squared, and this is equal to 2. Again, when x is equal to 9, then we have f of 9, 0, that will be equal to 2 plus 2 times 9 minus 9 squared, that will be equal to, now 2 times 9 is 18 plus 2, that is 20. So we have 20 minus 9 squared is 81. Therefore 20 minus 81, that is negative 61. Now notice that this function is a quadratic function, and thus it has either a relative minimum or a relative maximum somewhere, which can turn out to be an absolute minimum or an absolute maximum. So we need to find the derivative of this function, and then we set to 0 to find the value of x. We plug back into this function to find the value of the function at that point. So let's try to find the first derivative of this function. Therefore, we have f prime of x0, that will be equal to, this goes to 0, and then we have 2 minus 2x, and then we set that to 0. We try to find the value of x, so we have 2 equals 2x, we divide through by 2, and then we have x to be equal to 1. Now we are going to put this value back into this function, and thus we have f of 1, 0, that's equal to 2 plus 2 times 1 minus 1 square. 2 plus 2 is 4, minus 1 is 3. Therefore, we have f of 1, 0 to be equal to 3. Now let's move on to line 2. So line 2, we have x to be 0, and then y changes from 0 through to 9. So for line 2, we have x to be 0, and then 0 is less than or equal to y is less than or equal to 9. So we have f of xy, that is equal to f of 0y, and that's equal to, so we have the function 2 plus 2x, so 2 plus, now 2 times 0 is 0, plus 4y, so we have plus 4y minus x square, so minus 0 square, that is 0, minus y square. So this is f of 0y. Now when y is equal to 0, we have f of 0, 0. Now we've already evaluated f of 0, 0 here, and that is equal to 2. So we can simply write 2 here, or we can try to put the value of y in here. Now if you have y equals 0 in here, this becomes 0, and that also becomes 0, and then finally you have 2. So we don't waste time trying to put in y equals 0. Next we have when y equals 9. So f of 0, 9, that will be equal to 2 plus 4 times 9 minus 9 square. Now 4 times 9 is 36. 36 plus 2 is 38. So we have 38 minus 81, and that's equal to negative 43. So this is the value of f of 0, 9. Again, this is a quadratic function. F of 0y is a quadratic function, so we need to find the relative minimum or relative maximum, which can either turn out to be an absolute minimum or an absolute maximum. So we try to find the derivative of this function, that is the first derivative of this function with respect to y, and then we have 4 minus 2y, and then we set that to 0. So we have 4 equals 2y, we divide through by 2, we have y to be equal to 2, and then we put this value inside of the function, so that we have f of 0, 2, and that's equal to 2 plus 4 times y, so 4 times 2 minus 2 square. 2 plus 8 is 10. 10 minus 4 is 6. So we have this to be 6. Now let's move on to line 3. Now for line 3, we have y equals 9 minus x. We have y equals 9 minus x. So y equals 9 minus x, and then we have the interval of x from 0 to 9 inclusively. So this is going to be slightly different from what we did for line 1 and line 2. So here we have f of xy, and this is equal to f of x. Now y is 9 minus x. So inside of the function given, we are going to substitute 9 minus x for y. So we have the function 2 plus 2x plus 4y. So 4 times 9 minus x squared, and then minus y squared. So in place of y, we have 9 minus x and then the square of it. Let's try to simplify this. So we expand and multiply. We are going to have 2 plus 2x plus 4 times 9, that is 36, minus 4 times negative x. So that becomes negative 4x minus x squared minus, now we have 9 minus x all square. So 9 times 9, that is 81. 9 times negative x is negative 9x. Negative x times 9 is also negative 9x. So that becomes negative 18x. And then negative x times negative x, that becomes plus x squared. So we multiply negative 1 across. We are going to have, here we have 38 minus 2x minus x squared minus 81 plus 18x and then minus x squared. So finally we have negative x squared, that becomes negative 2x squared, and then we have negative 2x plus 18x, so that becomes plus 16x, and then 38 minus 81, that is negative 43. So we have f of x 9 minus x to be negative 2x squared plus 16x minus 43. Now because this is a quadratic function, we need to find the derivative of this function with respect to x. So we have f prime of x 9 minus x, and that's equal to, we are going to have negative 4x plus 16, and we set that to 0. So we have 4x equals 16. We divide through by 4, and then we have x to be equal to 4. So we are going to put this value into this function, so that we have f of 4. Now 9 minus 4 is 5. So f of 4, 5, that's equal to negative 2 times 4 square plus 16 times 4 minus 43. 4 square is 16 times negative 2 is negative 32. 16 times 4 is 64, and then minus 43. Now negative 32 plus 64 is 32, and then 32 minus 43 is negative 11. So we have the value of the function at the point 4, 5 to be negative 11. Now at this point, we are going to compare all the values we've obtained. So what do you think will be the highest value? Now we have the highest value. Let's say we have a 6 here. We have a 6 here. And then we also have a 7 here. So I think this is going to be the highest value. So we have the highest value to be 7. Now if the highest value is 7, then that becomes the absolute maximum value. So that is 7. And then notice that this 7 occurs at the critical point. So, and occurs at the critical point, which is the point 1, 2. Next, let's move on to find the least value. That is the absolute minimum value. So for the least value, we have negative 11 here, we have negative 43 here, and I think we had negative 61. So this happens to be the least value. So that is negative 61. Negative 61. And it occurs at which point? It occurs at the point 90. So it occurs at the point 90.